Hello, it's Scott Manley here, and we are getting near to the end of Cassini's long voyage through space. The spacecraft was originally launched on board a Titan IV on October 15th, 1997. It's worth noting that this was the only deep space probe ever launched on the Titan IV. All of the other missions launched would be Earth observation hardware, mostly for the National Reconnaissance Office. On the same day in 1997, a guy called Andy Green driving the Thrust SSC also set the land speed record in the Black Rock Desert. That record still stands today. 1997 also saw the debut of Harry Potter, the first singles by the Spice Girls. Radiohead released their magnificent OK Computer, and in LA, Biggie Smalls, aka the notorious B.I.G., was gunned down in a drive-by shooting. And in Paris, Princess Diana died in a car crash. Oh yeah, and a little known movie called Titanic was released, while astronomers like myself would spend many a night out staring at the great comet Hale-Bopp, unaware that our fundamental model of the universe would soon be changed by the discovery of dark energy. Look, you get what I'm saying. It's been a long time and a lot of things have changed. Cassini was the heaviest interplanetary spacecraft ever built. It's almost 6 tons when fully fueled. Just over 300 kilograms of that was the Huygens probe, which was going to land on Titan. The mission was actually a collaboration between NASA and ESA, with ESA handling most of the construction of the Huygens spacecraft. While its ultimate destination was Saturn, its large mass meant that it had to undergo several gravity assist maneuvers before it could get all the way out to the ringed planet. The spacecraft would fly past Venus twice, once in April in 1998 and later in June 1999. In August 1999, Cassini flew past Earth about 1,200 kilometers above the surface, giving itself a gravity boost of about 5.5 kilometers per second. That was of course sufficient to carry the spacecraft on to an encounter with Jupiter. Now on the way there it did pass by asteroid 2685 Mazursky, but it didn't get particularly close. The Jupiter encounter was centered around December 30th, 2000, and of course while it was there just to pick up the extra speed to carry it to Saturn, it did employ its new instruments to get much better pictures of Jupiter than any other spacecraft before or since. Galileo had of course been there for several years, but its camera was older and the spacecraft had a downlink issue. Meanwhile, the Juno spacecraft that is now in orbit, it can actually get more detailed images of the cloud tops, but the camera isn't part of the primary mission. And so Cassini's portrait of Jupiter remains the best we have to this day. After leaving Jupiter, the spacecraft would be in deep space for 3.5 years. But even in deep space, scientists can find something for the spacecraft to do. In September 2002, the spacecraft and Earth were on opposite sides of the Sun, and scientists back on Earth took the opportunity to measure radio transmissions passing near to the mass of the Sun, and in doing so they verified predictions of general relativity to 50 times greater precision than any previous test. By the end of February 2004, the spacecraft was now close enough to Saturn to get better images of the planet than were possible with any ground-based telescopes. In May, the gravitational force of Saturn began to dominate over that of the Sun, and Cassini formally entered the Saturnian system. In June, it flew past Phoebe at a range of 2,000 kilometers, getting our first close images of this moon. And on July 1st, Cassini crossed the ring plane between Saturn's F and G rings. Its antenna was turned forward to act as a shield against any potential debris. After that crossing, it was time for its capture burn. This would be a 626 meters per second deceleration, which would put it into a highly eccentric Saturnian orbit. This capture maneuver also placed them very close to the ring plane and allowed them to get some of the best pictures of their rings early on in the mission. During the next few weeks, the spacecraft would fly out to Apoap's while scientists continued to analyze the data it had already acquired. In middle of August, they announced the discovery of 2 new moons, Methone and Pallene. The first image of Methone was from June, a month before the capture maneuver, but the first image of Pallene It was actually discovered to be in a Voyager image. It had only shown up in one Voyager image, but the data from Cassini allowed them to determine an orbit and project it back and discover the original image. On August 23rd, there was the second major orbit adjustment maneuver. They fired the engine and provided 325 meters per second of delta V, which raised the periaps up above 300,000 kilometers. This put the periaps well outside the ring system, but it also put the spacecraft on a close approach of Titan. The next few orbits would include flypasts of Titan, and ultimately they were preparing to release the Huygens probe. However, in the meantime, a bit of a problem had been discovered. The Huygens spacecraft was designed to communicate its data back through Cassini. However, a design flaw was found in the receiver system. Now, as you can imagine, with spacecraft flying around at several kilometers per second, there is an appreciable Doppler shift in the signal. And the designer of the receiver was aware of this. They had ensured that the bandpass on the filter was wide enough to accommodate the Doppler shift that was expected during the Titan encounter. However, they had failed to take into account the fact that the Doppler shift would also adjust the timing of the signal. So the signal processing hardware would be expecting a carrier signal with pulses at regular intervals. However, the Doppler shift would change these regular intervals very slightly, and they realized after testing that the signal sync would be frequently lost and have to be reacquired, during which time data would be lost. Technically, it was a software problem, but unfortunately it was software which couldn't be updated after launch. So the navigation team had to come up with a way to fix the encounter so that the Doppler shift was minimized. So the orbit was adjusted so that during the Titan descent, Cassini would be traveling sideways relative to Titan instead of straight towards it. This would, however, mean that the gravity assist maneuver they had originally designed for the Titan encounter was not going to happen. And of course, the navigation for the rest of the mission had been designed around this encounter happening and giving the correct delta V. So after this encounter, they had to perform an extra burn to put it back on the original track again. Huygens it turned out that they had plenty of delta V. Many of the planned trajectory correction maneuvers had been unnecessary. And so Huygens was actually able to send data back to Cassini. Although it didn't send quite as much as I expected because there was another software bug that meant that one of the receivers was not turned on. Regardless, they still collected 350 images from the probe as it descended into Titan's atmosphere, and the images are amazing, especially when you consider that it is a 40 kilopixel imaging system running with about 1,000th the amount of light you would get on the Earth. On the surface, it was possible to see pebbles, which were actually made of water ice. And from high up, it was very clear that the structures looked like they were shaped by the flow of liquids. The amount of data that could be sent was limited because Cassini would fly beyond the horizon, but telescopes back on Earth continued to listen to Huygens long after Cassini had gone. And with that major event over, I think it's time we stop following the detailed timeline of Cassini and talk about the awesome stuff that it found on subsequent orbits, subsequent encounters with the moons of Saturn. After Titan, probably the most interesting data to come out of Cassini has been that of Enceladus. Early in the mission, close flybys of Enceladus showed that it had a thin atmosphere, and later that that atmosphere was mainly composed of ionized water vapor. Photographs showed plumes rising from the surface, and in 2008 Cassini flew so close to Enceladus that it passed within these plumes and was able to identify things like water, carbon dioxide and other hydrocarbons using its mass spectrometer. Data from Cassini has pretty much led to Enceladus being regarded as one of the most likely places in the solar system for extraterrestrial life to have formed. Cassini made a huge number of observations of Saturn's rings. It fired radio signals through them, it flew over them, it viewed them edge on, it viewed them from behind. It got every kind of illumination angle possible to identify the structure of the rings, the size of the particles. It looked closely at the moons within the rings and it found them generating waves due to their gravitational influence. But even just looking at the rings themselves, they were able to see structures called propellers, which were basically where large objects within the rings were disturbing the particles around them through their gravitational influence. And in 2013, they took this amazing backlit image of Saturn and its rings, which also included the planet Earth. And everybody had been told to step outside at that time and smile or wave at Cassini. So if you did that, you're in that picture. Cassini's long stay at Saturn let it analyse the atmosphere with much better detail than was previously possible. In particular, the famous hexagon at the North Pole was observed and it appears to change colour over time. Cassini was also able to follow Saturn's Great White Spot, which is a giant storm that, while Cassini was there, it formed, it expanded, and then it broke up. The first phase of the mission allowed several flybys of Iapetus, and boy is it weird. Not only does it have this weird white and black surface that is very colour segregated, it also has this amazing equatorial ridge which forms some of the highest mountains in the solar system. This ridge runs all the way around the moon, and there are multiple competing theories as to how the moon could have formed with this, but no solid answers as yet. Iapetus was of course one of 4 moons discovered by the original Cassini, Giovanni Domenico Cassini of course, back in the 17th century. The other moons were of course imaged by the Cassini spacecraft, including Rhea, showing of course craters. We have Dione with this really interesting wispy terrain, possibly indicating an active crust. And Tethys, which has the distinction of being one of the most reflective moons in the solar system, possibly because it's sitting in the middle of the E-ring and is being sandblasted and polished. Mimas was discovered by William Herschel in the 18th century, but when it was first imaged by the Voyager spacecraft, well, everyone remarked that it looked rather like the Death Star. And then as the moon sizes get smaller, of course, they start to become irregular. Now, Hyperion was actually the first irregular moon to be discovered. Of course, back when William Herschel discovered it, he didn't have any clue as to its shape. Now, Hyperion is also fascinating because it's one of the few moons that doesn't have a stable axis of rotation. It wobbles all over the place with a period of about 30 days. Now, we already looked at Phoebe. It was observed on the way in, but it's worth noting that Phoebe was the first moon to be discovered using photographic techniques. I think it was also one of the first moons to be discovered orbiting retrograde, and for a long time it was the outer-most moon around Saturn. Of course, Voyager changed all that. Janus and Epimetheus are of course fascinating because they essentially share the same orbit and periodically swap places when they come close to each other. The tiny satellite Prometheus is also a shepherd satellite for the F-ring, and you can see that it actually has some interesting effects on the ring due to its gravity. Similarly, Pandora sits on the outer edge of the F-ring. Helene is an example of a Trojan moon. It actually sits in the same orbit as Dione and sits in the leading Lagrange point. Dione also has a moon called Polydeuces sitting in its trailing Lagrange point, but it is so tiny and this is the best picture we could get. Telesto sits in the Lagrange point leading the moon of Tethys, and Calypso sits in the trailing Lagrange point. Atlas is one of a couple of moons which were discovered to look like flying saucers, or perhaps ravioli. What really is happening is that there is an equatorial ridge where a ring material is just being deposited, and the rings are so thin that it forms into a high ridge. This effect is even more pronounced for Pan. With the moons are actually thicker and are larger than the rings. So when the rings are viewed edge on, you can see the moon actually sticks above and below the ring system. Look, I am just sharing things in the broadest possible strokes here. Cassini has spent over a decade at Jupiter. It has orbited something like 290 times. It's travelled millions of miles. collected 650 gigabytes of data, discovered 6 new moons, and yeah, it is just finally reaching the end of its mission. And the real reason is, since it has been shown that moons like Enceladus are potential places for life to have formed, it's decided to protect these regions, these places, as pristine as possible. So Cassini is being sent into Saturn. Its periapse is now deep inside Saturn's atmosphere. Its transmitters have been set to transmit everything in real time, and an army of radio telescopes will no doubt be listening, trying to collect any information they can from this grand Viking funeral of this most amazing spacecraft. It will be a long time before we see a mission on the scale of Cassini again. NASA simply isn't sending spacecraft of this size anymore, and technology has of course made everything smaller, so there's no need necessarily for a mission of this size. And so it is rather sad that the best decision is to send this hurtling to its doom deep inside Saturn. The carefully assembled components of Cassini will disintegrate under the stresses of re-entry and mix into the atmosphere of Saturn to be lost. But while Cassini will leave no permanent physical impression on Saturn, the Huygens spacecraft will remain on the surface of Titan. It only had limited battery power, so it is long dead, but perhaps future explorers may one day visit Titan, and they may look for this, representing humanity's first landing in the outer solar system, and a physical reminder of Cassini's magnificent voyage which started 20 years ago. I'm Scott Manley. Fly safe.